divided by the degree at which they are inclined. For example, if we have taken two mirrors, two plane mirrors, and this is one plane mirror and this is another plane mirror. If they are inclined by maybe 90 degree, then the formula will be 360 divided by 90, that will be 4. So now 4 is the even number. That's why we have to subtract it from with 1, that will be 3. So if the angle between two plane mirrors is 90 degree, then the number of images formed will be 3. Let's, for example, another example is 360 divided by maybe 40. So here the answer will be 9. Now, if it is the odd number, then we have to keep it as it is. It will be 9 only. Next point is reflection. So you must be knowing about reflection, that is bouncing back of light rays after hitting any surface. This is a plane mirror, and if light is going in this direction and it is coming back, that is the reflection. And you must be knowing about different types of mirror. One is concave mirror, when there is the reflecting surface curved inward. When it is going inward, that will be, this is the concave mirror. And this one will be convex mirror, where the reflecting surface is bulging outward, that is the convex mirror. The concave mirror is also known as converging mirror, and convex mirror is otherwise known as diverging mirror. The next is refraction. So what is refraction? It is different from reflection. In refraction, what happens? When the light ray passes from, yes.
Sorry, ma'am. Ma'am, what is the meaning of converging and diverging?
Okay. Converging means when the light rays are getting reflected. That means if we are taking the concave mirror. This is the concave mirror. So when there are different light rays, for example, different parallel light rays are coming in this direction, then when they will be reflected, they will come back. So in this case, they are converging. At this point, they are meeting one another. So that's why it is converging mirror. And in convex mirror, it is diverging. Like for example, if parallel rays are going in this direction, so they will go away from each other, the reflected rays. That is diverging. Are you clear with this?
Yes, ma'am. Yes, thank you.
Okay. Next is refraction. So in refraction, what happens? When the light rays go from one transparent medium to another. For example, this is the air and this is the water maybe. So here two mediums are transparent. Here one, the light ray will go in this direction, and after going from air to water, what will happen? The speed will increase or decrease according to from which it is going or coming. So based on that, that will bend a little. That process is known as refraction. This is the process of refraction. So as you can see, air is a lighter medium. This is very light, and water is a little bit denser medium. So if anything which is going from a lighter medium to denser medium, then obviously the speed will decrease. So if speed will decrease, then it will move towards the normal. Normal is the point. Let me draw another diagram. So if this is the point where the light ray is coming. This is the light ray, this is the air, and this is the water. So at this point where the incident ray is falling, at that point we will draw a 90 degree. So this 90 degree line is known as normal. So if there would not have been any medium, it would have gone straight. एटी जदि किछि मीडियम न थांता ताले सेटा स्ट्रेट रे जाई थांता, सीधा पळे थांता. But now what will happen, as the speed is decreasing, so it will move towards the normal. It will move towards the normal, so it will bend a little and will go like this. Are you clear with this?
Yes, ma'am.
Okay. So next move to the second slide. When a ray of light passes from one medium to another, the wavelength and velocity changes, but the frequency does not change. एथिरे बस एतकी मन रखियार अछि कि frequency केबे भी change होबोनी, आउ सबु change होबो. एबे doubt आस्तुबो, what is wavelength, what is frequency? So whenever there is a light ray, it may be moving in this shape. So wavelength is the distance between the two waves. This is the wavelength. And frequency is the number of times it is moving. For example, this is 1 second. We are taking it in 1 second. There are 3 waves. So here if we will compare it with another wave, it is also moving in 1 second only. So this is case 1, this is case 2. In 2 cases, you can see in the first case, as it is moving only 3 waves in 1 second, and in the second case, there are 1, 2, 3, 4, 5 waves in 1 second. So in the second case, frequency is more. And in the second case, frequency is less. This is the concept of frequency, and wavelength is the distance between 2 waves. This is the wavelength. So whenever the light ray passing from one medium to another, frequency never changes. Wavelength can change, velocity can change, but frequency will not change. Human eye has convex lens. As we can see through our eyes. So in our eyes, there is a lens present, which is the convex one. Convex lens shape hochi a type ro, bulging outward at both the ends. So this is the convex lens which is present in the human eyes. Least distance of distinct vision is 25 centimeter. That means आमे minimum 25 centimeter दूर रे किछि गोटे जिंस रखिले ही आमे देखि परिबा. This is the least distance. ताठु कम रे रखिले हमको clear vision देखाबन. This is very important. 25 centimeter. And here I have shown the electromagnetic spectrum. In this spectrum, not to get confused, there are different waves. As we will move towards the right, you can see the frequency is more here. In this case, frequency is more. And when we will move left, the frequency is less, wavelength is more. So this gamma rays, the gamma rays have the highest frequency and the lowest wavelength. Wavelength of frequency inversely proportional. गोटे बड़ा हेले गोटे अधिक हेले आ गोटे कम हबो. तो gamma rays रो सबुटु बेसी frequency. Next, defects in human eye. Sometimes we wear glasses or spectacles. So first is the myopia. Myopia is known as nearsightedness. तो मायोपिया रे कौन हम आमको पाख जिनसटा भलरे देखा होथबो किंतु दूर जिनस हमको भलरे देखा हबनी जोटा हम मानकु नॉर्मली हुए कम एज रे बिलो 40 एज रे जोटा हुए हमरो सेटा कहंती नियर साइटेडनेस एंड द करेक्टिव लेंस दैट इज वन इज कॉनकेव लेंस तो आम माने जो लेंस पिंधुचु जो चश्मा पिंधुचु ता सेथिरे जो लेंस यूज होची सेटा कॉनकेव लेंस रो शेप हेथाय just like this is the concave lens and heterometropia is the opposite of myopia तो ताको कहा जाउची फार साइटेडनेस माने एठी दूर जिंस देखा हबो किंतु पाख जिंस देखा हबोनी जेमति कि नॉर्मली हमरो घरे फादर मदर पेरेंट्स करो जो प्रॉब्लम हेथाय तांको पाख जिंस देखा हबोनी किंतु दूर देखा हबो दैट इज नोन एज द heterometropia and the corrective lens used is convex lens. So as you all know, convex lens ro shape ए type ro. So one is myopia, one is heterometropia. ए दीटा बहुत important. Next is presbyopia. Presbyopia रे कौन हुए जते बेले लोकों को बहुत एज हे जाए सेते बेले हमर लेंस उडा को बहुत हेजी हे जाए ता ऊपर गोटे कवरिंग आस जाए सेटा को आ जाउची presbyopia. करेक्टिव लेंस सेथरे यूज हुए बाइफोकल लेंस केबे केबे देखिथिबो गोटे गोटे चश्मा रे एमती तळ पटे गोटे लेंस थिबो ऊपर जगह रे आ गोटे टाइप रो लेंस थिबो सो दैट इज बाइफोकल लेंस so these three are the defects in human eye. Next is the refractive index of vacuum. Refractive index होचे गोटे टाइप रो कैलकुलेशन कि केते बेले भी हमर लाइट रेटा एयर रो वैक्यूम को पास करची कि वैक्यूम रो एयर को लिक्विड को पास करची सेते बेले तार गोटे कैलकुलेशन होचे रिफ्रैक्टिव इंडेक्स सो रिफ्रैक्टिव इंडेक्स द वैक्यूम रो होचे 1 and refractive index of air is 0.0001 तो ए वैक्यूम और एयर को सब बेले इक्वली मानंती 1 ही धरा जाए and the brilliance of diamond रो जो एते माने कोन शाइन थाए that is due to the high refractive index जेमती वैक्यूम रो होची 1 रिफ्रैक्टिव इंडेक्स तेमती डायमंड्स रो बहुत हाई रिफ्रैक्टिव इंडेक्स थाए जोथि पई कि तारो शाइन टा बहुत अधिक थाए एंड द टोटल इंटरनल रिफ्लेक्शन टेक्स प्लेस रिफ्लेक्शन यू ऑल नो सो इंटरनल रिफ्लेक्शन मींस ता भितरे ही गोटे डायमंड जदी थिबो ता भितरे जदी रिफ्लेक्शन बार बार होची गोटे साइड रो आ गोटे साइड को रिफ्लेक्ट होची पुनी आ गोटे साइड रो आ गोटे साइड को रिफ्लेक्ट होची ता भितरे ही इंटरनली रिफ्लेक्शन होची तो सेटा को जाय इंटरनल रिफ्लेक्शन so that takes place in the diamonds here you can see the diagrams of one is myopia another is hypermetropia then application in everyday life so in application we see atmospheric refraction so this you have to understand a little bit when there are different layers in the atmosphere this is the atmosphere
Yeah.
yes
Hello, ma'am.
yes ask
Ma'am, refraction means yes, ma'am. Refraction means reflection.
reflection alga refraction alga
Am I audible?
yes you are
Sir,
audible
refraction, sorry, ma'am. Yes, ma'am. What is the meaning of refraction? What is the difference between refraction and reflection?
reflection जते बेले हबो देखो जते बेले reflection हबो सेते बेले सेटा बैक करिवो गोटे सरफेस रे टकरे कि सेटा बैक करिवो that will bounce back this is the reflection किंतु रिफ्रैक्शन रे कोन हबो सेटा बैक करिवोनी सेटा गोटे ट्रांसपेरेंट मीडियम रु आ गोटे ट्रांसपेरेंट मीडियम को जिवो जेमति कि एयर रु लिक्विड को जिवो लिक्विड जोटा वाटर आमे गोटे एग्जांपल नै परिबा तो एयर एमती गला एयर रे लाइट रेटा गला तापरे सेटा पछको आसीबोनी पछको जदी फेरी आस्तांता सेटा रिफ्लेक्शन हो जायतांता सेटा आ गोटे मीडियम को पळेबो वाटर को बट सेटा टिके बेंड हे जिवो एटा हे जिवो रिफ्रैक्शन
Yes, ma'am.
Clear?
Thank you. Yes, ma'am.
Okay.
Clear. Thank you.
So in this atmospheric refraction कोन जोटे atmosphere रे होतबो same as the refraction atmosphere रे हमर different layers थाए depending upon the density of the air present in the atmosphere. तमरो unmute mute कर दियो please. So when the layers of atmosphere have different density, for example, this is the heavy, this is the light. So when the light ray will pass in this direction, then there is the chance heavy light माने होची गोटे ओजन थिबो आ गोटे हल्का थिबो. So if light ray is going from one direction to another, from one layer to another, then what will happen? For example, it is going like this. This is the light ray. So now what will happen? The speed will change. कहीं ना हल्का मीडियम रु heavy medium को जाउची तो speed कौन हबो? Speed कमी जिवो. So there is a chance that it will bend a little. So एठी भी गोटे type रो refraction हैला. So a refraction as it is happening in the atmosphere, it is known as atmospheric refraction. So atmospheric refraction पाई हमारा day to day life रे तार किछि applications अछि. One application is twinkling of stars. माने स्टार टा जो ट्विंकल करे गोटे पोजीशन लो आ गोटे पोजीशन रे बेले बेले देखा जाए सेटा होचे twinkling of stars and that is due to atmospheric refraction. So all these points you have to remember. Another one is early sunrise and delayed sunset. See, this is the twinkling of stars. Actual star position is here, but the apparent position is somewhere else. माने गोटे पोजीशन ले स्टार एक्चुअल रे थाए किंतु आ गोटे पोजीशन रे सेटा देखा हुए बेले बेले. So that is due to atmospheric refraction. Next is early sunrise and delayed sunset. So here you can see true position is below the horizon. Horizon तले true position थाए and actual ले जोटी present थाए किंतु बेले बेले कौन हुए आमर जेहेतु atmospheric refraction होची सेतिपाई आमर तार जो पोजीशन टा सेटा ऊपर देखा जाए horizon रो ऊपर देखा जाए बा horizon तले थिबो ऊपर देखा जिवो ऊपर थिले केते बेले तले देखा जिवो. तो सनराइज जो हुए sunrise is 2 minutes early and sunset is 2 minutes late. That's why delayed sunrise and early sunrise and delayed sunset. तो total हमको 4 minute extra time पे देखा जाए sun देखा जाए and that is also due to atmospheric refraction. Next application is rivers appear shallow. माने जो आमर नदी थिबो सेटा भी आमर बहुत माने गभीर थिले भी सेटा लागिवो कि ऊपर जाय अछि. Coin in a beaker filled with water appears raised. Coin टा हमको बेले बेले ऊपर हे के देखा जाए माने तळे थिबो एक्चुअल रे किंतु सेटा ऊपर देखा जिवो. That is also due to atmospheric refraction. And pencil appears bent. As you can see from the diagram, the pencil appears a little bit bent. So this is due to atmospheric refraction. These all are the applications of this phenomenon. Next we will move to dispersion. This is another concept. First one was refraction. This is dispersion. Dispersion re kon hobo na white light ta satota different color re seta divide he jibo. जेमति कि आमे गोटे प्रिज्म नबा. Prism has been taken, white light छड़ा हला व्हाइट लाइट टा डिवाइड हे गला सातटा कलर रे तो ये जो सातटा कलर रे डिवाइड हैला सेही प्रोसेस को कहा जाउची डिस्पर्शन so when rainbow is formed rainbow is also application of dispersion there are different types of phenomenon taking place in the rainbow formation for example here you can see from the sun light is coming towards the water droplet जेतेबेले भी तम हमरो रेनबो देखा जाए से टाइम रे कोन होता है हल्का हल्का वर्षा होता है तो से जो वाटर ड्रॉपलेट्स थाए से वाटर ड्रॉपलेट रे जोठी आसी कि हमरो सनलाइट ता इंसिडेंट हबो ए पॉइंट रे तापरे कोन हबो जेहेतु एटा एयर मीडियम रू वाटर को जाउची so obviously the refraction will take place माने से लाइट रे टा बेंड हे जिवो तो सेति पय एठी रिफ्रैक्शन हला ता सहित आ कोन हबो सातटा डिफरेंट कलर रे सेटा डिवाइड हे जाउची so that process is known as dispersion and another process which is taking place is total internal reflection internal reflection diamond रे हमें बुझितिले कि सेटा ता भितरे जाय कि इंटरनली ही सेटा पुनी जाउची पुनी इंटरनली वाटर ड्रॉपलेट पाखरु ही सेटा रिफ्लेक्ट बैक करूची एठी बाउंस बैक करची पछकु फेरुची सेति पय एटा को हजिबो इंटरनल रिफ्लेक्शन so here if question will be asked what are the processes which take place in rainbow the answer will be refraction dispersion and total internal reflection all these three then scattering scattering रो अर्थ होची गोटे लाइट रे जते बेले तारो पार्टिकल्स थ्रू रे जते बेले सेटा मूव करू थाए तारो पाथ टा देखा जाय माने सेटा डिफ्यूज हे जाय जदि गोटे लाइट रे हमें गोटे विंडो रु आसुची घर भीतर को सनलाइट रो रेज उडा भीतर को आसुची तो सेई टाइम रे हमर कोन हबो लाइट रे रो पाथ हमको देखा जाउची कि को पटे लाइट रे टा आसची सो दिस is one of the example of scattering and this is known as the Tyndall effect this is the Tyndall effect
मैम स्कैटरिंग माने जो विच्छुरित है कि लाइट पड़े दैट इज स्कैटरिंग
हां 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 विच्छुरित है कि विच्छुरण हो जाए सेटा को स्कैटरिंग कहा जाए
ओके मैम
तार आ गोटे भी एग्जांपल एठी देखि परिबो हमर फॉरेस्ट रे कि कोठी भी गच्छ जते बेले गच्छ तळे देखिले भी सनलाइट रो छोटे छोटे माने रे एमती अलगा अलगा रे पूरा देखा जाए सेटा को जाउची टिंडल इफेक्ट एंड इट इज द टिंडल इफेक्ट इज द एग्जांपल ऑफ स्कैटरिंग आउ स्कैटरिंग रो आउ कोठी एप्लीकेशन अछि डे टू डे लाइफ रे द ब्लू कलर ऑफ द स्काई स्काई रो जो ब्लू कलर टा सेटा कोन पे ब्लू देखा जाए काहे कि ना जो व्हाइट लाइट टा हमर 7 कलर्स रे तयारी हिचे तार जो ब्लू कलर टा सेटा पूरा स्कैटर हे जाए चारियाडे so that's why the sky looks blue and another example is red color near the horizon during sunrise and sunset सनसेट और सनराइज टाइम रे हमें देखंती कि होराइजन पाखटा माने जोठी सनसेट होथाय बा सनराइज होथाय सूर्यटा जोठी माने उठुथाय ऊपर को सेही जगह रे हमर रेड कलर देखा जाय दैट इज आल्सो वन ऑफ द एग्जांपल ऑफ स्कैटरिंग so I hope all the concepts are clear but now we will go through some of the questions so that we can check how much we have learned. So first question, if two plane mirrors are inclined at 40 degrees to each other, then how many images will be formed? Options are 7, 8, 9 and 10. Okay, Gitanjali, Swapneswar, they have given the right answer, that is 9. The formula is 360 divided by theta. Theta is the angle. So here the angle is 40. So here answer is 9. Next question, What happens when light travels from a denser medium to a rarer medium? ଯେତେବେଳେ ଡେନ୍ସର ମିଡିୟମ ରୁ ରେୟରର ମିଡିୟମ କୁ ଯିବ ସେତେବେଳେ ଆମର କଣ ହବ? ଲାଇଟ ରେ ସ୍ଲୋ ହେଇଯିବ ନା ସ୍ପିଡ ହବ ସେଇଟା ଫାଷ୍ଟ ଦେଖିବାର ଅଛି। ନର୍ମାଲ ଆଡକୁ ମୁଭ କରିବ ନା ନର୍ମାଲ ରୁ ଆୱେ ମୁଭ କରିବ? So first tell me if it will slow down or speed up. Okay.
Speed up.
Yes, it will speed up and it will bend away from normal. So the answer will be D. Speed बढ़ी जिवो तो speed बढ़िबो माने सेटा normal रू दूर को पळेबो। Normal हमें देखिथिले normal होची जो 90 डिग्री जोटा एंगल करथुबो सेटा को आजिबो normal। Next question, the phenomenon of light being deflected when traveling obliquely from one medium to another is called what? Reflection, refraction, diffraction or dispersion? गोटे मीडियम रू आ गोटे मीडियम को गला बेले सेटा डिफ्लेक्ट हो जाए माने बेंड हो जाए। वेरी गुड स्वप्नेश्वर, दैट इज रिफ्रैक्शन। Question number 4. Splitting of white light into its 7 constituent colors is known as what? Dispersion, atmospheric refraction, scattering, total internal reflection. Yes, Manashri, Swapneshwar, very good. The answer is A. Next question. Twinkling of stars is an example of which among the following? We just have discussed twinkling of stars. Very good, Gitanjali. Lalit, very good. Sabita, yes. So this is atmospheric refraction. Next, to correct the condition of, so here it will be, it will be hypermetropia. To correct the condition of hypermetropia, the patient will wear which type of lens? Concave, convex, bifocal or none of the above? Hypermetropia. Yes, Barsha has given the right answer. Okay, Suprabha, very good. That is convex lens. Can you tell me hypermetropia is otherwise known as what? Nearsightedness or farsightedness? Okay, farsightedness. Very good. Question number 7. Reddening of sky near the horizon during sunset is due to which phenomenon? Reddening of sky. It may be, it can take place during sunrise or maybe during sunset.
Scattering.
Very good. Scattering. Question number 8. Least distance of distinct vision is 22, 23, 24, 25. How many? Very easy question. 25 centimeter. Question number 9. To see distant objects, which of the following can be used? दूर जिनस देखिया पे हमें कोटा यूज करिबा? माइक्रोस्कोप, कन्वेक्स लेंस, टेलीस्कोप, कॉनकेव लेंस. Yes, Kadambini, you are right. Telescope. Next, which type of lens is present in human eye? Human eye रे को type रो lens थाए? Try to answer. Okay. Convex. So this is all for today's class. If you have any doubts, any queries, you can ask me. Any doubt, or you are clear with the concept which we have discussed today? Okay. So in this class, we will try to take the important concepts of general science. Okay, then. Thank you, class. Thank you so much.